Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 12. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as 2 independent current sources IA and IB. The question now is to find the currents through each resistor. Let's move on to the solution. In this network, all branches are connected in parallel, resulting in an equal voltage across each branch. Let's start first by labeling this node as node 1. And after, I will assign the voltage VO to this node. Next, we need to select a reference node in the network. The reference node is typically chosen as the node with the most connections or as the ground node. Let's assign now arbitrarily the currents in each branch. And I will consider I1 is the current through R1, I2 is the current through R2, I3 is the current through R3, and I4 is the current through R4. Next, we will proceed to apply Kirchhoff's current law in the node 1. By applying Kirchhoff's current law in node 1, we can write IA minus I1 is equal to I2 plus I3 plus IB plus I4. According to Ohm's law, the currents can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equations. I1 is equal to VO over R1. I2 is equal to VO over R2. I3 is equal to VO over R3. And I4 is equal to VO over R4. By substituting now A, B, C, and D in 1, we can write IA minus VO over R1 is equal to VO over R2 plus VO over R3 plus IB plus VO over R4. And by replacing the currents and the resistors with their numerical values, we obtain this expression. And if we combine all the terms of this equation into a single denominator, we obtain the following expression. And if we continue simplifying this expression, we obtain 12VO plus 720 is equal to 0. That means VO is equal to negative 720 over 12. We get negative 60 volt. Now from equation 1, we have I1 is equal to VO over R1. If we replace VO and R1 with its numerical value, we obtain I1 is equal to negative 60 over 10 is equal to negative 6 amps. And from equation B, we have I2 is equal to VO over R2. If we replace VO and R2 with their numerical values, we obtain I2 is equal to negative 60 over 20. We get negative 3 amps. And from equation C, we have I3 is equal to VO over R3. If we replace VO and R3 with their numerical values, we obtain negative 60 over 30. We get negative 2 amps. And the last one is from equation D, we have I4 is equal to VO over R4. If we replace VO and R4 with its numerical value, we obtain negative 60 over 60. We get negative 1 amps. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here this is the independent current source IA, independent current source IB, resistor R1, R2, R3, and R4, I connect here a non-parameter in series in order to measure I1, in order to measure I2, I3, and I4. Let's move on to analysis. This say analysis, calculate nodal voltages. We can see here that the current I1 is equal to negative 6 amps, I2 is I2 is equal to negative 3 amps, and I3 is equal to negative 2 amps, and I4 is equal to negative 1 amps. After completing the simulation, we clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another example about nodal analysis. Take care and bye bye.